All right, so 1.5, the verbal models. Actually, one more quick thing really quickly that I wanted to talk about. Hey, when you guys take your next quiz, I'm going to be hiding these notes. So I'll still post them. So whatever I'm about to go through, I will create PDFs of them and I'll post them here. But those are not going to be allowed to be used during your quizzes and tests. Okay? Now you can take it at any time, take the information off of them and put it into your own notes. And you can use that, but I'm going to hide these PDFs when you guys are taking quizzes and tests in class. Again, just to give you a heads up on that. All right, so let's take a look at a few problems. The verbal models, we've done so many of the story problems. There's not a whole lot new in this section. It's just a series of applied problems. But I want to go through a few examples here really quickly. All right, so here is a problem. A rectangular garden has an area of 125 square feet. If the length of the garden is 12 feet, what is its width? And so, again, this shouldn't be anything that's too new to you guys. It's just a matter of taking your verbal model, finding a picture to illustrate the relationship, converting that picture into an equation, plugging in the correct values, and solving the equation. And so if we were to imagine this, we have this rectangular garden, and the total area is 125 square feet. If the length of the garden is 12 feet, so that means this total length from here to here is 12, what is its width? So this value W would be what's left over. And so what this requires is it requires you to know some simple formulas or equations. And if ever you don't, just raise your hand and ask me, and I'll either direct you to it or give you the equations. Any of the equations that I don't expect you to know, I'll try to write and embed in the problem itself. But what would be the area formula for a rectangle? Area equals what? Length times width. A real easy one. And so using this equation, you could plug in your information. So 125 is your area, your length is 12, solve for W. And so you can either use the calculator, solve for W, or you can do it by hand. This winds up being a pretty simple calculation. You divide both sides by 12. You get W is equal to, again, 125 over 12. Put a decimal in it so I get my answer in decimal form. And you get about 10.4 as your solution. Okay, so this is, again, pretty simple use of a formula. Area formulas are very common, and there might be some other real common formulas that you'll be using as well. Okay, hopefully there's not a whole lot of questions on those type of problems. The next kind, there might be a few more, but still it's pretty straightforward. And this is most likely new to you guys, but they started off pretty easy. All right, what they are going to give you is a set of problems, or a set of inputs and outputs, and ask you to find a pattern that exists in these. Okay, the process for finding this pattern is, again, pretty straightforward, and all of the examples that you're going to be given in this are linear patterns. Anybody, you guys have heard the term linear, right? You guys know what that means? What a linear equation or a pattern that's linear means is that if your x's or inputs increase at consistent intervals, so in this case every 1, right? So 1, then 2, then 3, the y's are going to increase also at a consistent interval. The rate of change is the same. Okay? So it has a consistent rate of change or a consistent slope. So what you would do here is you find the change in outputs. Okay, so how do these outputs change? Between every two y's, it increases by what in this case? Each one is 3. Okay, so if you find that the outputs increase by the same value, that is your rate of change. Okay, this is your slope, or your m value. Okay, once you find this, so right now the equation that we can create is y is equal to 3x. So all we need to do here is find the b value, and that's found by finding the value of y, your output, when your input or x value is 0. This is your y-intercept, or in the case of what we're looking at, the b value. Okay, so we're using this form y equals mx plus b, the linear equation, standard form, or slope-intercept form. Okay, and so what is our y value when x is 0? 0. And so this is our equation. We can simplify it just to 3x. Never write a plus 0. And don't write multiplication like a coefficient of positive 1. If you have a coefficient of negative 1, don't write negative 1x, just write negative x. Okay. I want you to kind of use the same idea and see if you can find the following patterns. Oops. All right, can you find the equation that models this information, please? All right, do all the y's change by the same amount? Each incremental y changes by 4. So there's your rate of change. So you're looking at y equals 4x, and then it's plus or minus. What is our y-intercept? 1. It's the value of y when x is 0, and so we have our answer. All right, one last one, just to make sure that it'll involve some negatives, so there's no confusion. All right, so look to see if you can create the equation that models this information, please. Right, what's the incremental change in the y's? Each one is negative 2. Since those are all the same, that's your rate of change. So y equals negative 2x, and then what was the y-intercept? Plus 0, which you don't need to write, so you just leave it as y equals negative 2x. That is your equation. Right? Questions about those patterns? They're pretty simple. Later on, we'll talk about how to find patterns that aren't linear in nature. And so this is a good place to start for that. All right, the last example is another story problem. All right, so here is the problem. And you're designing a square flower garden that's surrounded by a brick sidewalk of uniform width. if the garden has a side length of 6 yards and the side of the outside square is 10 yards, what is the width of that sidewalk? So what I want you to do is just take a moment, see if you can sketch this and identify what the width would be, please. So here's our square garden with a uniform sidewalk around it. Okay, and it says the following: the garden has a side length of 6 yards, so that's this distance in here is 6. The side of the outside of the square is 10, so this whole length along here is 10. And then what it's asking you is find the width of the sidewalk. Well, here is the width of the sidewalk right here. We'll call it W. Well, not only does that have a width, the left side also has that uniform or same width. And so how do all these pieces relate to one another? It's basically just a sum of parts is equal to the whole. So this W plus 6 plus W, okay, so the sum of all three of these parts has to add up to this long part of 10. And so now it's just a matter of solving those. Okay, so if you combine your like terms, 2W plus 6 equals 10. Subtract 6 from both sides. And then isolate and solve for your W value. So you get the width to be 2.